So hi guys, welcome back to another videos about calculus 2. So today we're gonna continue with another techniques that we're gonna use to find the volumes of the solid formed by rotating a curve about the y-axis or the x-axis. So, mm, so this technique is called the cylindrical shell. So the reason why that we use the cylindrical shell instead of using the dishwasher method that we already discussed this on last video. So basically some volume problems are impractical to solve by the methods of dish and washer. So instead we slice the solid region differently into shells and add up the volume of all the shells. So what I mean by saying that, so let's consider a problem that will build up the formula that we're gonna use in this technique. So now let's consider a cylindrical shell of H, H, and the inner radius is R1, and the outer radius R2. So we go ahead and sketch the shape out. So we will have a really big circle over here, and then the smaller one inside. So we will draw a bigger cylinder and then a smaller one. Connect these two circles, and we have the in the smaller cylinder inside and the bigger cylinder outside. So how can we find the volumes of the outside parts over here? Outside part over here. How can we find that? We don't consider the volume inside the um inside the smaller cylinder. We just find the volume that is limited by the the inner cylinder and the outer cylinder. So how can we find that volumes? So the volume will be the volume of the bigger cylinder minus the smaller one, right? So it will be the volume equal to pi r2 square h minus pi r1 square h, and we will put pi h outside, and then on inside the bracket we will have r2 square minus r1 square, and then we can simplify this to something by using the algebra formula. So it will be pi h r2 minus r1 r2 plus r1, and from this I will set up the equation something look like here, and I will tell you why I do that later. So because I divided the sum of r2 and r1, so I have to multiply it outside, so it will equal to the previous equation. So now if we call r equal to r1 plus r2 over 2, the average radius of the shell, and also r2 minus r1 equal to delta r is the thickness of the shell. So the thickness is here, the thickness, this is the thickness. So we will have the volume equal to 2 pi h r and then delta r. And from this and this shape can also be seen from something look like here. Oh, I'm so bad at drawing, sorry. So it will look something like this. Oh no. So this is h, and this is 2 pi r, and this is delta R. So to find the volumes of the um, cuboid, it will be the products of the width multiplied by the h multiplied by the length, right? So we have the following formula. If the region under the curve y equal to f of x from x equal to a and x equal to b is rotated about the y-axis, the volume of the solid form is v equal to the integral of from a to b up to by x, f of x, and then dx. So dx is the thickness, and f of x will be the h, and x will be the radius. So that this is exactly this one over here. So it is h, this is radius, and this is the thickness. So it is the same as the thing that we have over here. So